Hi class, today we'll do the lab for assignment problem. There are two parts in this lab. The basic difference between these two parts is we use different way to input two-dimension parameter into our games model. In this lab, we use table command. Keys of this lab. Because the assignment problem is a very essential in OR field, we must know it very well. And then we build a mathematical model for assignment problems. After that, we implement a games model for assignment problem. Once we finish the games model, we can change different parameters to play the model to get more insights of the assignment problem. The general description of the assignment problem. There are some assignees, such as operators, to perform tasks, such as jobs, which has the same number of assignees. We denote the number is n, which means we have the same number for assignees and tasks. One assignee performs exactly one task. We denote the index I for assignee. One task is assigned by exactly one assignee. We denote the index j. A cost Cij is associated with assignee I performing task j. The objective is minimize the total cost. Of course, we can use other objectives. For example, we can replace costs by efficiency and profit. And then the objective can change to maximize the total efficiency or total profit. In these slides, we generate a scenario for our games model. We can see the following table in the downside or cost matrix here. For column 1, 2, 3, 4 represents different operator. For row is for different job. And the number in table, for example, like this one, is C14 equals 7 is the cost of the operation 1 performing job 4. If we build a model, we can change our scenario a little bit. For example, we have a constraint that says the first operator can only perform the second job or the third job. So you can find some difference or implication for these problems. And also, we can change the objective. And we will find why this objective value will change, or we use different objective, and we have different results. This one is the mathematical model for assignment. The first one here, minimize z, is summation Cij, Xij, which means we want to minimize the total cost. And Xij here means that if the value is 1, means the operator I performs job j. Otherwise, the value is 0, So through the binary variable, we can set up the objective and the two constraints. For the first constraint, we said for every operators, the operator only can does one job. And for every job, only one operators can perform the job. Okay. So now we can go to the games software to build this model. Of course, we need the table to input our parameter so that we can run the model and see the results. Okay, so we go to the games and we open the new file here. And then now we have the two index I and j, right? So we put sets I, and then we have 4 operators, and then we have 4 jobs. Okay, we can see the slides here, right? We have the 4 operator and 4 jobs. And then now we need to input the parameter into our games model. If we don't use the command table, how we can input the parameters for this table? Okay, so maybe we use the parameter Cij, right? Then we use the C1 equals to 3, and the C1 2 equals to equals to 8, and so on. Okay, so it's really bothering for input the data by this way. So can we use something like one-dimension data input, like 1, 1, 3, 1, 2, 8, and so on? No, you cannot do this. What you can do is here. You must input the data one by one. So if you have the two-dimension parameter, normally we will use table command to input the parameter. Okay, so we type table here. We have the C, I, J. Okay, we have 1, 2, 3, 4. Very similar to your table. The column here means the operator I, and the row here 1, 2, 3, 4 is for jobs. So we put a number to corresponding location. Is 3, 8, 10, 7, 5, 3, 3, 3, and 4, 6, 9, 6, and 5, 4, 10, 6. Okay, if we do this, we can check the results. If we already input the two-dimension data set, we can use display C. Okay, and and run the model. Okay, let's see the display here. C equals what we already input the two-dimensional data set. Okay, and then we can build others like binary variables x, right, ij, and free variable z, right, and we construct objective by equation obj, and for operator I and job j. Okay, here you will see for array we can use something like this symbol parenthesis inside is I, like function of I, right, here. Like for every I, we have one equation. So in this scenario, we have 4 equations. Okay. For the job, has the same meaning. After that, we determine the function z equal to sum ij cij times xij. And for operators, only can do one job. And for the job, only one operator can do one job. Here should be xij. Okay, then we give the model a name. Model assign or. Okay, so we already built a GANs model for assignment. What we see here is exactly almost the same as our model here, only symbol difference, right? Only symbol difference. Okay. And finally, we want to solve the model. Right. So assign using MIP, minimizing z. Okay, so we finish the model and run it. Okay, the optimum value is 16, and we'll see the results x. Okay, so the first operator doing first job, and the second operator doing third job, and the third operator doing the fourth job, and the fourth operator doing second job. Okay. So now, what you can do, okay? What you can try now is you try to make a new data set and implement by yourself. Okay? If you forgot how to build a model, you can see this video. And also you can compare different results by different objectives. Okay? And also you can make an algorithm by yourself to examine your algorithm is better than these results or not. Okay, So now we have the result here, and we can try to make our own algorithm for sequential. Okay, what is the sequential algorithm? Okay, or maybe I remember. Okay, here we can assign the job for operator one by one in sequential order. First one, we assign the job for operator 1, okay? Because now we want to minimize our costs. So I choose this one to assign the first job to first operator because it has lowest cost. And for the second operator, I can either choose the second, third, and fourth, okay? And I choose the second here. Okay? And then we assign the job for the third operator because now we already assigned the first job and second job to the first two operators. So we only have the job 3 and job 4 for the third operator. So we choose the job 4 because between these two costs, 6 is lower than 9, right? And then finally, the last one only can do is the third job. So now you can edit all the number by what we have already found. 3 plus 3 plus 6 plus 10. So the number is 22. Okay, so you can find your own algorithm is not as good as the result from the model, right? Remember the model, the result is 16, right? The z here is 16. Okay. Okay, so maybe you can try to make your own algorithm and find a better solution. Okay, so we go to the other parts of this lab. Bye bye.